Dziękuję. Preferujcie zielony przycisk. Będzie dobrze. Okay, zaczynamy. All right. That's supposed to be an English spoken speech. So, all right, let's get started. High time for a continuous delivery talk. So, I'm Szczepan Faber. I live in Krakow, and I'm an automation freak. So, automation is my thing. Anyone automates his tests with Mockito library, maybe? Mockito? There you go. Half of the, majority of that. Beautiful. And maybe some of you automate your projects with Gradle. Oh, two little hands, guys. I need more Gradle users. All right, so I'm obsessed with quality. It's been 10 years since I started doing extreme programming, and it took me another few years to actually get it right. I'm like, if anyone worked with me or had training with me or some coaching engagement, you know that I'm pushing really hard for high quality tests and high quality design and production code. And Mockito is one of the libraries that has really nice code quality. At least I think so, I hope so. Every now and then I get some emails from, I don't know, students of PhD or masters, and they want to do some research on Mockito code quality. And yeah, so I provide them data and they do this research, and I hope it's doing fine. And generally, Mockito codebase is really nice, the coverage is great, I have those manicured tests and everything is beautiful. And yet, I release Mockito every 2 years. So there's something not working there, isn't it? Like having all that beautiful code and all those test automation should remove all the fear from doing the releases, should make it easy, should make it automatic, but it wasn't for some reason. And for the past 4 years, there were like two releases. So what happened was there was this genie that materialized in front of my face, and his face was just Humble's face, and he slapped me. That was a Zen slap, and I knew that I need to do a proper continuous delivery with Mockito library. It's funny that I've been doing continuous delivery, helping out clients, Gradle clients, with automation, with getting all the behaviors needed in order to implement continuous delivery. Yet Mockito was released every 2 years. You know, there's something wrong there. So let's get into that. And I'm not going to tell you what continuous delivery is. You can read that in the book that I showed before. For me, the way I conceptualize continuous delivery is this is like a black belt in continuous integration. So as the team matures and automates more and more and cares more and more for automation, for test quality, for better automatic verification of the correctness of the application, they naturally adopt the behaviors that we associate with continuous delivery. So they get to that mode. So continuous delivery does not mean that you have to push new version to your client every 5 minutes or something like that. Not at all. But it's definitely something that you're going to be doing if you treat continuous integration properly and you invest and you grow and you continuously improve. There you go. You're going to get there. So for me, it's like continuous delivery is like continuous integration evolved. It's one other thing is that it's a mindset. So in theory, tools don't matter. It's the mindset that is important, that you believe that every build is a release candidate. So every check-in to the source control, be it Git or Subversion, whatever you use, can be a release. So this is a mindset. It's something that if you set as a goal, that you're going to see that you're going to develop a bunch of practices and bunch of patterns you're going to have to implement to get that happen. All right. So obviously you need to automate a lot. You need to have a lot of quality automated tests. But these days, automated tests is mainstream, so everyone does it. Anyone read the book, Continuous Delivery book? Nice. About 1/3 of the people. Very good. This is another book that I'm reading these days, and it's probably the best book I've read in the past 6 months. One of those psychology books for masses. And I'm always under influence of some book of that kind, and since I was reading that just yesterday, I had to somehow relate that to continuous delivery. So this is a book of for the habits, to understand what habits are and how they control us. So how does it matches the continuous delivery? So continuous delivery as a goal, and then you have those behaviors and patterns, some things within your control that you can do, you can change in order to get closer to continuous delivery mode. Those are those good habits that you can implement. And once you start developing those good habits in your organization, your team, even in yourself, you're going to see that they ripple. They go into other teams. They can change organizations. They can change individuals. So this is pretty amazing. One of those good habits could be always ensure that the build is green all the time. Ensure that your builds are, not longer than 10 seconds. Like, I'm not sure if you've been to Daniel's talk yesterday. So those are the good habits that if you focus on, you're going to see that they're going to change everything. They're going to change your organization. You're going to be naturally going to this operational excellence. Costs will go down. Profits will go up. The team is going to win. So good habits that, when properly established, they're going to basically rise more good habits. And I'm going to be talking about good habits of continuous delivery, of the things you can do to get there. And the book is pretty good. It's not related to IT at all. So, this. All right, on the menu. So I'll start with Mockito. Then I'm going to go to Gradle. And then I'm going to talk about some patterns that either I've implemented for our clients in Silicon Valley or other places, and other things that I've learned from people I work with, or presentations I've seen on the web. So in 2007, 2008, I was very keen on beautiful tests that are easy to write and less brittle, and I really like this cocktail, Mockito. Who likes mojitos? I'm buying mojitos after the presentation. If you push the green button, maybe. So generally, what I wanted to achieve with Mockito is that I want everyone to be able to be proud of the code he writes. The test code is code, so I want you to be proud of the test code that you write. That was the fundamental principle. Everything else felt like less important, like slave principles to that one. So I want you to be, okay, can you bring up your IDE and show me the test that you have written on Friday, let's say at work, and to show it to everyone and to be proud of it. Anyone can do it? I'm really proud that this is, who wrote a test on Friday? Oh, nobody, okay. Oh, yeah, somebody. Are you proud of this test? Would you show it here? Maybe. How many mocks does it use? 12, okay, that's not so bad. So I want you to be proud of the test code. And the test code is code. I mean, I was always a believer that focusing on the test code quality is pretty much enough, because high quality tests will push really high quality design architecture of your application. There's well-written tests that are easy to maintain, clear and beautiful. For a poorly architected production code, they don't exist. You can't write, clean tests for a crappy production code. That's not possible. Provided that you do tests on all the levels, so unit tests, integration tests, and those kind of tests. So I want you to be proud, like this lady here, of your tests. That was the fundamental principle behind Mockito, and there you go. And I haven't been releasing that much recently. And also, I want to show this recipe I have for you for writing good object-oriented code. So combine those two ingredients. This book, who maybe read the Growing Object-Oriented Software? Come on, show me your hands. For sure, more. There you go. There you go. A couple of people. Definitely, so don't look at the JMock examples. So you should prefer to use Mockito. So yeah, Steve Freeman, Nut Price, excellent book, and JMock, not too bad. Mocking framework. So Mockito has become popular from the early days, from the 2007, 2008. This is a chart from Git. So Git, what they do is from time to time they basically measure the popularity of various libraries, and they basically break that down onto different technologies. So for the Java projects they've tracked, several dozen of thousands of projects, a pretty nice number. They came up with the Mockito all being at the 9th, so in the top 10 of the Java libraries. But there's also Mockito Core, right? And the Mockito Core is the same thing as Mockito all. It's just the packaging is slightly different. And the Mockito Core is number 12 or something like that on the list. So if you combine the results from Mockito all and Mockito Core, Mockito gets into the position number 4. So basically goes here. So basically, in theory, it gets into the top 3. So you get Log4j, you have JUnit, you have Mockito, as far as popularity of the mocking framework, which is pretty nice. which is pretty great, but yeah, but how come I release only every 2 years? Like, it doesn't work. So I wrote an email to the Mockito mailing list, and I'm asking, hey guys, we need to do something with those releases. It doesn't make sense that we release so rarely. And the reason why we rarely release is that we have less time. We have families and little things running the house and stuff. So there's a good chance that there are other things that I need to be doing right now. So yeah. So and I decided, hey guys, let's do continuous delivery. It's gonna be cool. It's gonna be fun. And and the feedback was, no, you're crazy. That means poor quality product released. There you go to all the users. And there was something not right there, because the goal of continuous delivery is to increase the quality, is not to reduce it. So like, what's going on there? So why they are worried? Are they worried that the code that they write, the code that they push is not top standard, so that we can't release it? We need to have manual testing, like manual testing of Mockito. Yeah. Okay. So and there was it. Like I figured that out. So I was like, so the Zen slap I received from Jazz, like quality is irrelevant until it's not delivered. So that's important. Like if it doesn't matter how beautiful my tests are and how beautiful my code is if it's not delivered, if it's just pushed in. And let's go extreme on that. Imagine that the code that you're going to write tomorrow, and you're going to push that in. You're going to check that in this code tomorrow. You're going to be working. The value of this code is 0, null, until it's released, nothing. Let's say on Friday you have iteration, you finish your iteration, and you get the story points and stuff. Who gets on this Friday? Who gets his iteration completed this Friday? Oh, okay, cool. A few people, all right. So and imagine that you get those story points for completed stories. I tell you this: those story points mean nothing if the stuff is not released. Story is closed, but what does it mean? It's closed. If something is not released, it has no value. Actually, it even has a negative value because you have to maintain it. It takes away build cycles and stuff. So this is the mindset I was striving for right now. So like, it needs to be delivered for it to actually have any value. And we want to do valuable things. We want to release often. So in Mockito 1.9, the releasing was no fun, at least for me. So I had this fear for releases, and it's funny. The thing that I hated most about doing the release was creating release notes. So I always wanted to mention every contributor by name and just basically build a good log, and I wanted to be funny and all that stuff in those release notes. And then it took so much time that I just postponed it all the time. And then releases were rare and more rare. The backlog was growing, the things we need to look into that, and it was totally demotivating. So the community was concerned as well. So there was even a few months ago, if you look at the main page of landing page of Mockito.org, you would see, hey, breaking news, Mockito 1.9.5 was released in 2012 sometimes, yeah. So it's like, well, is this library alive? So one thing I want to say here is that when there is not a lot of development in certain library, and I'm not talking about Mockito right now, it does not necessarily mean that the library is dead. Sometimes it means that basically it's mature enough that it does not need more features. So from my standpoint, Mockito was complete at version maybe 1.3. So that's all I needed to write clean tests. But then there were use cases growing for edge cases scenarios where we started adding some certain features. Mockito has pretty slim API by today as well, so it's not that it grew too much. But generally, I need only a very basic set of features in order to test drive a clean, nicely architected code. And remember that also when you write tests, and every time you write a test, and it's hard for you to write this test. And you think hard, how do I do it? How many mocks do I need to use? And Mockito does not have the thing in the API that I need. And I need to use Power Mockito. Maybe not, we'll see. Or I need to use something else. Then my idea for that, basically, is that you should think about the production code. Well, if you are test driving, it doesn't matter if you do test last or test first, right? Let's consider the test first scenario. You are trying to come up with the test case, but you can't. It's kind of hard to write this test. You spent half hour and you didn't come up with a test case, with a test method, right? So there's something wrong. You need to refactor. You need to continue refactoring until you can come up with a test method in 15 minutes. And then with a clean test method that basically that shows the essence, what behavior you are basically describing in that test case. So that's my thing. Like, think hard how to refactor your code so that it's easy to test drive, so that it's easy to test if you do the test last. Who is doing test first, by the way? Test first? Oh, nice. About like 15 people. Test last? Oh, okay. That's the same equal number. Test never? Okay, hopefully nobody. Well, a few hands, okay. Right, so starting from Mockito 1.10, we removed all that stuff. So one of the visions I had for Mockito is that I'm not gonna do another release. I'm not gonna do it if subsequent releases won't be automatic. Because the shortest path I could take is just to release that thing, and just I could forget about it for the next 2 years or so. Unless the users are thinking, Szczepan, do the release, come on, man. So, so I decided that I'm not going to do this anymore, never. I'm going to set up the automation in a way that once I do 1.10 release, every next release after that is completely automatic. I push the code to the GitHub, and it's done. It's happening. So that's to sort out those problems that we had. The challenges here is automation, but it's not really that much of a challenge. I'm the automation dude, so I'm like, I can figure that out. And especially the tools that we have today, the tools that I've been using made it so easy to do this automation. Like a few years ago, I might not implement it because it was just too time consuming to sort out everything. Now these days we have the tooling. And then quality assurance, I don't know if it's a challenge, but in theory, there is something in the back of the head that if I push and it gets released, is it going to be high quality enough? I don't know. You know, I need to be sure. I need to do it manually to actually ensure that this is good quality. No. So nothing like that. Let's make sure that all tests are that we have a great automatic verification, automated tests for Mockito that are doing interesting stuff. Not only they validate features, they validate like thread safety and whatnot. So ensure that we have that automation covered, so that it's not becoming a challenge. It's just become it's not a problem. So Mockito model at this stage is that every push to Git leads to a new version, and it's not a snapshot. Who likes snapshots? You know, it's a tricky question. Nobody wants to show his hand. Yeah, Daniel, you like snapshots? No. Okay, fair enough. Okay, you hate snapshots. Fair enough. I hate snapshots too. They don't work for me at all. So like new version, proper version. Release notes and documentation is also generated. And especially the thing that I love most is that automatic generation of release notes. And I even mentioned the contributors. I need to show that. I need to demo that because this is so cool. So let me, hang on. This is like where we are. So let's do Chrome. Okay, let's go to Mockito. So release notes page. Okay, let's take a look at this version. So they are not beautiful, maybe. They could be, nicer, but that's something that we can sort out. For now, they work. So take a look at that. This is version 1.10.8. I haven't touched anything with that version. So like Bryce, one of the contributors from Paris, he added a fix, and this is pretty amazing. So basically, what happened is that I finished working and stuff, I went to sleep, and I wake up in the morning, check out my emails. Oh, new version of Mockito was released. Oh, cool. I'm wondering what are the features in Mockito. And I take a look. Oh, Bryce fixed one of the bugs. Pretty awesome. So this is like, and it felt so good that, that we've set it up to that point where the community can really embrace that, those features that we have and basically contribute. Bryce actually, he did that fix, I think, in the plane. So basically, he flew to New York and basically he received information about this bug. On the plane, he fixed that. He pushed that at the airport before he went somewhere. It's there. It's like, obviously, this is all, we add the coverage. We add the test. There's a test automation around that. So this is not something. Those are not like dirty fixes and things like that. No, not at all. So Not everyone has commit rights to Mockito, obviously not like everyone. Bryce is one of the contributors that has. So, and then yeah, there is a new version of Mockito. Okay. So, so release notes automated, documentation similar. I can release from my phone. I've even done that once. So there was one feature I take on my phone, and there's a pull request. I'm diffing the thing in my phone, and then it looks, it requires some fixes. So I gave the feedback, he did some fixes, and I gave more feedback, he did more fixes, and then I merged that from Git, just pushing that button in Git to merge the pull request, and there you go, new version was released. Isn't that awesome? Well, it wasn't from phone, sorry, I was lying to you, I was just building the suspense. So I did it from my computer, but I didn't use my IDE at all. So it was all in browser. So I was doing other things. So, you know, there was an email coming in, I did the review, feedback, so feedback loop, he iterated on the code a little bit, so I haven't touched the code at all, just reviewing from GitHub the diffs and providing feedback. And there you go, it was pushed. I could do it from the phone, though, I could. So in theory, it's under 10 minutes to get the new version out. It's usually faster, it's usually about 5 minutes. But I can't guarantee that because this is all built on the open source stack. So there's no server that I maintain, that I own. This is all open source, which means that I'm using free plans on some of the tools that have also plans for commercial purposes. And basically, when you are on the free plan, for example, in Travis, you know, you don't have a guarantee that the build will kick off in like a few seconds after you push. But it's usually a couple of minutes, and which is perfectly fine for me. Now, the most beautiful thing about the Mockito model at this stage is the new energy that I see in the community. It's just so enjoyable to work on the feature where you know that it's going to be released very soon. Once that gets into the code base, it's released. You know, like, I'm not sure if you worked in that environment ever. It's like, that's the nirvana of like contributing to open source, right? You contribute and it's immediately available to everyone to consume, for you to consume. You don't have to mess around with snapshots, with, I don't know, custom version released to your own Maven repository, things like that. It's there, it's released. So this is where we're striving on. And that brings more energy, like way more contributions, very interesting contributions. It's really happening, and it's so nice to observe that and like helping out. I'm like, these days, my vision is to build some kind of a model continuous deployment using the open source stack so that it's reproducible, so that you can take that whole thing and basically use it in your open source product. So that's my vision. So I want to extract plugins out of the code that I write so that you can reuse them. Generally, that's what I would love to have. We'll see how it goes, how much capacity I have. But generally, that's where I'm striving for. So I'm completely sold onto the automation. Those are the tools that I'm using. Travis, GitHub, and Bintray for doing stuff. And there's this beautiful tool in the middle. This is the master. Those other tools are kind of slaves to that, to Gradle. Great tools. So Gradle orchestrates all that stuff. So there's a built-in Gradle that does everything, and I'm using those other tools like Travis CI. So this is a continuous integration server, GitHub at the top, and Bintray. You can think about Bintray as improved Maven Central, something much better than Maven Central, much more flexible. Generally, a place where you host binaries, but not only binaries, but where you host things that people will download. So how it works? Someone pushes to GitHub. Travis gets that change from GitHub, runs the build, uses Gradle to do the build. If the build is happy, all the tests pass, and everything is cool. Gradle is publishing binaries to Bintray, so proper new version. Actually, recently, just like a few days ago, I've added a feature to Mockito automation to not release new version if the binaries are exactly the same. Because sometimes you change a README file or do something really dummy changes that don't change the binaries and don't require releasing of new version. So imagine that before we had to watch ourselves, and every time we did a change to the system that we didn't want a new version to be released, we had to add a magic CI skip a message to the commit message. Otherwise, a new version of Mockito would be released, which would not have any features like, I've changed the README file, and there you go, new version of the library. So we don't want that. So this is something that I've developed like a few days ago. So like yeah, so we have got Bintray. Bintray is also integrate with GitHub in some way, but it's nothing really like spectacular. It's getting like information like README file. It's getting some data from GitHub. But I think from my standpoint, more interesting is how from my build that is run by Travis and Gradle, how we push stuff to Bintray. Some of the interesting tools that are related to that is that, so Travis needs to be able to push to GitHub, not only to read from GitHub. Typically, your CI server only might only need to read from your source control because it needs to get the project and build it, right? Now, since we need to have proper continuous deployment, we need to, from a Travis box, what needs to happen is we need to push a new updated documentation to GitHub, updated release notes into GitHub. We need to push stuff into GitHub. Therefore, we need to be able to write to GitHub. So there's an auth2 protocol, which is very nice. I don't have to compromise my username and GitHub username and password and store it somewhere on the box and stuff because I can use very nice mechanisms that are built in. So there's this auth protocol in GitHub. Basically, it means that you can create like a big string with like magic, like it looks like a unique string thing, and basically it authenticates. It's a part of the protocol. I'm not going to get into too many details, but it's very nice to set up. Also, I like really much the way Travis does it. So Travis is a CI system that, at least in the free plan for open source libraries, it does not allow you to have any state on that box. So I count, let's say, SSH onto the box that runs my CIs, and then, for example, drop a file with a password there. It's not possible. Basically, every build on Travis, it's basically a brand new, fresh virtual machine. The build runs in this fresh virtual machine, and then this virtual machine is destroyed at the end of the build. So it's completely stateless. So also the mechanisms and the authentication I do needs to be able to support that. And Travis is really nice. It gives you some command line utilities so that you can encrypt certain information that you want to keep secure. So let me just quickly go to src, and I'm go to the Travis file. So this is a configuration of the, oh wow, so many files. This is a configuration of the CI for, I'm not sure if it's seen, but you should see this like hieroglyphs and things like that. Those are the secure variables that can be encoded and safely checked in. So this is one of those things that makes building that deployment, automatic deployment easy, that the tools that we use now support those mechanisms for encrypting the secure information, and yeah, it makes it easy to use. Okay. Oh, and we also use GitHub REST API, which is pretty cool, to get the issues from GitHub so that we can build release notes. So the release notes in Mockito, they are driven by the GitHub the titles of the issues in GitHub, basically, which is very cool. And here's the reason. Once we automatically generate release notes from Git log and from the issues reported to Git, it introduces a pressure to ensure that your Git commits are clean and well linked to the tickets, and also it introduces a pressure to write good descriptions for your tickets, to write a good titles for your tickets. So which is very nice. And this is also what I observe when implementing more automation and continuous delivery. Basically, what you're going to see is that good behaviors will be, you're going to have to do good behaviors and good patterns. Otherwise, automation will not be able, you will not be able to do the automation, right? If someone missed the ID from the commit message, we won't be able to generate the release notes. So it's important to do those things. So it's very cool that having that automation in place introduces a pressure to do the right thing in other places of the workflow of the life cycle of developing code. Okay. All right. So Travis CI and Bintray. So how it happens that on the Travis CI box we're able to publish to Bintray. So I'm using Gradle build tool for building things, and there is Bintray has a REST API to publish stuff, to publish jars and libraries, but I don't want to do, I don't want to mess around with REST in my build build automation in my project. And there is a Gradle Bintray plugin, so there's a plugin for Gradle that allows me to very nicely declaratively publish to Bintray. Let me show you how it's declared in the code. So I've got in one of the Gradle files, I think that's published Gradle. There you go. I'm not sure if it doesn't look very well. Let me upgrade the font. How do I do it? I'm keen on showing that to you, so hang about. So let's change the font size. Come again? How do I do it? View? Where are you? There you go. Oh yeah, that's much better. So this is how it's done in my build.gradle file. So you can see that it's a nice declarative way. So I'm declaring things, and basically the build makes it happen. So there's a task that I can run that publishes to Bintray. You can also see that for the sensitive information that needs to be secured, we reach out to the environmental variables. So there's a system-env Mockito Bintray API key. So this is an environmental variable that is encoded in the Travis configuration file. So so I can safely check that in. And what Travis does when Travis starts building, he creates those environmental variables for me with decrypted value of those secret information, and I can take advantage of that in the build. So this is pretty nice. It makes it also easy to debug that locally and play around with the release model. So that's pretty cool. Bintray integrates with GitHub in few ways, but I'm going to go through because I'm running out of time a little bit. So in general, what I'm striving for is that releasing is fun and not a chore. So just actually in one of his presentations, he said that make releasing boring, so there's no adrenaline whatsoever involved. And I kind of don't want to think like that. I want to think about releasing as fun, like getting those features out to the community, getting the value. That's like we are coding for people and users to consume the features. I mean, we don't feel good if we develop a great application that nobody uses, right? It just doesn't make sense. So yeah, so happiness, and then it wouldn't be possible without this. It's not Hulk, it's Gradle. It's also green, but it's everyone will use Gradle at some point. So Gradle will take over the world at some point. All right, so let's go into Gradle. So Gradle release model is that generally every 2 months we release a new version. So right now we are in the process of getting 2.2 version out, so there's going to be some release candidates and stuff. A major version is every 1 or 2 years. And this release model we think that this is good for community. So it's not too often, and it's not too rare. Some of our users are, they don't feel good if we release too often. That's why we believe that 2 months is the right number. Because 2 months of development, it's still quite a long, so there's a lot of features that are done. I'm like if you compare that to Mockito that get released on every push, that's completely different. But Gradle is a tool on a completely different scale than Mockito. So there's the level of validation and tests in Gradle involved is much higher, and it requires way more than Mockito. Gradle has nightly builds, which kind of feel like continuous deployed version of Gradle, but I don't think they are. They don't go through that rigorous process as the regular releases, at least in Gradle. So that's why usually when we use nightly builds, even at the clients or where it's needed, we basically tell, hey, this is the selected nightly build that you can use to get something. So it's not like every nightly build can be used. I mean, every nightly build passes the build, so the build is green. However, Gradle has so many tests and so many coverage. We need to ensure that the build works on various combinations of Java versions and operation system versions and stuff like that. That this feedback cycle is pretty slow. Let's say to run the entire suite, all the tests, it takes a day. And so the nightly builds don't go through all that cycle. So basically, there is so nightly builds only the validation, that the most important validation, but it does not do the full cycle of the coverage that we have. So I don't feel personally, I don't feel that this is like a version that I would encourage to use. It's more or less for testing, for checking out whether the feature works or not. That's at least my way of looking at that. We have a lot of automated validation, and we have very credible tests. Now, and this model that we had was great until I had a bug in the system pretty recently. It was a ladybug, and this bug. And I fixed that in Gradle, this bug, which is all good. But then I need to wait another month or a few weeks for a new version of Gradle to get released, so that I can take advantage of that fix. And that bothers me. I want to get it out immediately. This happens like some time ago, and that started me thinking that whether it would be good for Gradle to do a continuous delivery and real continuous deployment. So I don't know if Gradle will do it at some point, maybe. But as a thought experiments, what are the challenges that I see in Gradle at the moment? Is that so the feedback cycle from the automated check is pretty slow. So we've got so many tests. Let me just go to the browser. That it takes time to run. So you can see some. Let me just increase the font size. There you go. So we've got. You can also see the build pipeline, which is considered like a manifestation of the continuous delivery. So basically, you have various stages where the change goes through the system through various stages where more and more rigorous validation is applied to the change, and also the binaries travel through. And at some point, it's when the build is completely green and all the stages are green, let's say it's releasable. Yeah. So we have all those kinds of builds, and it's. Let's take a look at full coverage, for example. So we have some coverage here. So it's a Linux on Java 6. There are cross-version tests. There's a daemon integration test. There are parallel integration tests. There's a Java on IBM. There's a Java 1.6 IVM vendor. There's quick test for 1.8. Like all those kinds of things. They are slow. And then also some of the tests are flaky. And we work on making those tests reliable all the time, but still flaky tests happen. And you have one flaky test, and basically you have a problem. Your full the change won't go through the entire build pipeline. It's going to stuck at somewhere because the test will fail. So I'm going to show in a second some patterns around the flaky test, but I'm mentioning it as one of the challenges. And one of the other things is detecting who introduced the problem. Let's say, if the feedback cycle is pretty slow and after several hours we discover that there is a problem with Java 1.8, we don't necessarily know which change has caused that, given that during the day there were like 10 developers committing code. So that's also something that needs to be improved in order to get this machinery with the continuous deployment working. So those are the challenges, but one thing I want to leave you with is that Gradle is extremely nice automation. So this is the stuff that we do regarding the tests and things like. One of the presentations I have is the automation that we do that makes the Gradle releases and building Gradle possible. So that's like the kinds of tests that we do. It's really amazing what Gradle does. It's really state-of-art automation. Yet there are always challenges. We always can be better. We always can be better. So the patterns. I want to tell you about patterns of that I see that organization implement in order to get continuous delivery working, or the behaviors for continuous delivery. All those good things around automation to actually make it possible. Some of those patterns are things that I've helped implementing. Some of those patterns is I've learned from someone, so I'm going to be telling which is which. So welcome, Silicon Valley. And then one other thing I want to say is that continuous delivery is not something that alpha geeks do, when they are doing university and stuff. This is real companies, real big companies, multi-billion-dollar companies are doing continuous delivery. So like Amazon, Facebook, Flickr. Those guys release at least daily, like Facebook as well. So it's like the release. This is happening. That's something that is there, that industry does. This is not something that only alpha geeks do. It's there. Okay, so flaky tests. So I used to think that flaky test is evil and it needs to be changed and fixed. We always have to strive to get them fixed and always spend time in fixing them. And for some reason, maybe I'm getting older, so I came to peace with flaky tests. So I discovered that they are the part of the world, right? It's like, it feels that at certain scale, and especially, cheers, thank you. At certain scale, when you do, especially when you do integration tests, you have, those things will happen, because like, it might be a human error that you've introduced the test that works beautifully, but after a few weeks it's going to fail the first time, let's say. So those things, the things like that happen, and then I believe that the approach for that is to model that, to understand why those tests are failing, like understanding. Okay, this is a flaky test, we know about it, but how often does it fail? How often does it fail for a wrong reason? How often does it fail because the test can fail for the right reason, which is like it shows that there's some problem with the code that we need to fix, or it can fail for another good reason, for like because it's flaky, because because there was a full moon yesterday and that's why the test failed. So that's also a possibility. So how often, what's the ratio, right? How often does it fail for the right reason, for the wrong reason? Those things like that. And what I've seen is that companies are modeling that stuff. So like, it feels that from the standpoint of clean code and clean tests and extreme programming, like retrying a test, oh, we should never do that. And these days, I no longer think like that. I'm more pragmatic. I feel that if I have a flaky test that fails once in a year, I don't care about it. I want to have a retry logic that retries it. Like, I mean, like, it also depends how difficult it is to fix the test and how useful coverage it introduces. So it all depends. Don't take me wrong. I think you should strive for high quality tests. But I also believe that at certain scale, flaky tests, are going to be somewhere. They're going to be around you. All right. So one of the other things is test selection, to understand what tests needs to validate. So it's interesting what Google. So there are a bunch of presentations how guys at Google do the automation around the test selection. Is that they can build, like, all the products are built from the single source tree. So how does it work? Well, because the incremental build is basically implemented at the state-of-art level, so they know exactly which tests to execute. So if you change some kind of a root library somewhere, that's a thing that hundreds of other components use, basically they will know which tests to run. They will know which components to rebuild. So so this is also important to have this test selection. And like, I believe that many of you have, like on your CI boxes, you do clean build, right? You just run all the tests. So it's one of the interesting things I saw at that Google presentation is that they say that that even Google cannot run all the tests for one change. It's like even having like immense computing power, like virtually limitless, they still need to do this test selection. The build needs to be incremental. Another thing is that dry running a change. So for the client I work right now, so the way it works is that I have some change in my local. Basically, what I can issue a single command from the command line, and basically what's happening is that it takes a change that I was working on. Just change for example, if I use Git, it'll take the commits that are not pushed, and will send this diff to the cloud. And basically, in the cloud, my build will be kicked off, but not only my build. Also, all the components that depend on me will be rebuilt. And let's say in 15 minutes, I got an email. Hey, your change is good to go. Your project has passed, and all the projects that depend on you are also happy with your change. So this is dry running a change. This is amazing. It requires, I don't know what are the, I'm not aware of like tooling like in open source stack that will enable you to do so. So usually what I see is like some in-house tools used for that. But this is pretty great. So tracking down a test failure to the commit is also important. So do it in a smart way. So probably it means that you need more computers, right? Because you need to run, you need to basically run tests based off a single push. Let's say we talk about Git. You can't just include changes for many people because you would not know which, when there's a failure, who is involved, who is the culprit. So that's one of the things. Another thing is knowing the good version of library. Given that you do proper continuous integration and you always work on the master, no feature branches. Who is doing feature branches? I don't want to see you. No feature branches. No feature branches. So, so if you work always on the master, you know that sometimes master might not be. So there might be something checked in that is not good. So there's a concept of last known good, which basically, so the tools that I've seen at the clients is you are able to check out a product with the good version, so you know it's going to be always working. So it's going to understand its state. So this is something that also needs to be modeled. And and then this is also a fundamental piece, and especially for enterprise, is basically understanding the graph of dependencies of the project in the organization. So I don't know anyone has that implemented in his organization? Yeah? Cool. So so this is great. It's like this is something that makes possible the feature that I talked before with sending my diff, the change that I was working on, to the cloud and rebuilding my project, but also all the dependent projects. So basically, an organization needs to know, needs to own the model. It can't be something ad hoc that, teams are working various things. If some teams are cooperating with each other, it's like nobody knows about it, only they know about it. It needs to be properly modeled, and once that's modeled, you can build automation around that. Yeah. Perceptual diffs is the promise, last slide, so I'm going to let you go home. So I've taken that from the secret safe continuous deployment presentation on the that I found. It's great. It's by one of the teams at Google. So basically, they say that they've implemented continuous deployment, and they were very happy with that until the client got a pony feature, released, and that was a virtually pony feature with a little horse pony jumping on the screen. Going there because basically some automation value there was not enough coverage, let's say. So they've invested, that team invested a lot in perceptual diffs, and they've set up amazing automation for detecting any changes to the web pages they produce there. So they actually can detect that something has moved 1 pixel to the left, for example, and they will detect that. So this is pretty amazing. There are tools, there are open source tools to do perceptual diffs. You actually can, they basically started, they started detecting the problems that humans were not able to detect. Because there are sometimes there are some bugs that are so cosmetic that you won't see it, that the button is moved a little bit, and even humans won't detect that, but the tools will detect it greatly. So basically this team has greatly actually benefited from that problem, because they built great automation around that, and they're just, this presentation is short, like watch it, it's great. And with that, I want to leave you with continuous delivery is a mindset, so start slowly incrementally, and then remember your code is worth 0, nada, null, until it's released. And I'm Szczepan Faber, thank you very much, and yeah, questions I'll take after the presentation because I'm out of time, sorry guys.
Thank you very much.